was saying, from Monday, what we have treated is, what have we treated? Our topic for this week is advanced smart contract development, right? So we've looked at how to use components, and then yesterday we looked at how to use this pattern mechanism to communicate with different contracts. So been following this week. Am I correct? No response.
We're here now. No response yet.
So okay, I've actually not, what was it called?
Listen to some. Listen to some. It's supposed to be.
So I've actually not oh God, what was this thing called? I've actually uploaded the recording of the previous class to YouTube.
What about the GitHub?
And my mistake, I actually forgot to send the repository to you. Oh, Jesus Christ. Sorry, give me like 3 minutes or less. So I'm going to send the link to the repository here. That's for what we have done so far.
Okay, okay.
I know this is like very looks a bit, but as I said, I was on the road and I'm just entering my house now. So give me some minutes to settle my head down. I hope you can forgive me. Using this pattern mechanism for contract interaction between two contracts deployed on Starknet. So I just sent the GitHub to the comment section now.
Okay.
And then I'm going to share my screen and we're going to continue where we stopped yesterday. Is that okay?
Yeah, it's okay. Let's go into it.
Network has been taking me out like
Okay.
very, very badly. Give me a few minutes. Let me see if I can stabilize it. I hate this. This.
Hold on, hold on.
Yes, you should pick on us.
Wow, so that's how Daniel looks. Daniel, you be fine, boy. And your room fine like this.
Very good. That's right. This is awesome. I think that, yeah,
Which kind of script?
yeah.
My
Like
life.
garage, I do. Don't be my garage. This is not my room. I'm in garage. Jesus, Jesus. Very good. This place is
So
garage.
can everyone see my screen now?
Yes, yes, we've seen it. Well, this contract food and components are not on the GitHub repo.
I know on the
They are not on the GitHub repo. The one I cloned now doesn't have
they are there.
this. What is it?
They are. Just you can check it.
Okay.
So the next thing, okay, were you able to implement an ERC20 last week? Can anybody remember? Can anyone remember?
So I think
No.
GitHub doesn't have those code that you have. The only thing here is just the SRC test and other guys. I think the
Did you use
branches.
the link I sent? Like,
Yeah,
is it the same address that I sent you're using?
yeah, the link you sent now. Yeah, this one here.
I doubt it's the same address. Anyway, the next thing, okay. Can you see my screen? You can see my screen now,
Yeah,
right? Trying to do in 6 places at once. Check the link I just sent to the words to the chat now. This is there. Look at it now. Open this. Open the source folder, and you are going to see components, contracts, lib, and types. Exactly how it is. Do you understand?
yeah,
Exactly how it is in the code base. So everything is there. Where we stopped yesterday is that, okay, recap of what we did yesterday, by the way. We we were able to implement the components, right? A start, we implemented these ownable components from scratch, and we highlighted the differences between a component and a contract. So when you're writing a component, you write it almost exactly the same way as you're writing a contract. Components is just a piece of logic that is separated from the rest, in order to make code more readable, in order to avoid repeating yourself when you're coding, or for whatever other reason. But that's the principal use of a component. What you are just doing is you are separating chunks of logic into another place instead of putting everything in one file. And it helps in the sense that your code, as I mentioned, your code is more readable. Sometimes you need to do separation of concerns. Like in one smart contract, you can be handling 4 different kinds of um 4 different kinds of tasks. Like I mentioned, a contract that is implementing a company, for example. The company will have different departments. The company will have the financial department. The company will have the HR. The company will have maybe research and development. So if you want to implement all this in a smart contract, it's possible to write every single thing with all the functions you need inside of one file. But it's more advisable to separate your concerns, like say you are separating the different departments into different components, and then consume those components within the main contract. That's just how Starknet components work. The principal difference between a component and a contract is that you can't deploy a component while you can deploy a contract. Do you understand? Can everyone see him? Can everyone see him?
yeah,
Okay. So I don't know why I feel the need to go over this. for the sake of those that were not here yesterday. Components also use interfaces just like contracts. So we define our interface here just as we would if we were writing a contract. And the next thing we did is we came down here to declare the model. But instead of the decorator being in a contract, the decorator will be something like Starknet contracts. But since it's not a contract we are using, it's a component. This is what we have instead. Starknet components. I call the component enable components. Imports are as usual because it's the same Cairo language we are writing. A component, just like a contract, must have a storage. So I implemented the storage struct. I implemented the events. I did just one event, ownership transfer. Then the next difference is that if you have been following from the beginning of contract deployments, you will remember that there is a particular function in a contract that runs only at deployment time, which is called the constructor. Now, since you cannot deploy components do not have constructors. That's another difference. Because whatever is in the component is going to be initialized when the component is used within a contract and that contract is deployed. Are you following me? Like if you are following me, please. Okay. The next thing is that this implementation block is not the same with a contract, in the sense that, first of all, the decorator is not ABI embed v0 if we want to expose it. Instead, we have to say embeddable as this. So what this means is that, sorry, when we want to use this component inside another contract, we're going to refer to it using this name, enable implementation. So pub implementation enable. And then this is not, I'm not going to go over this again. It's in the previous class. We explained this in the previous class. But this is how to declare the implementation block in a component. It's not just importing this and saying contract states. It's component states wrapping the T contract states or T, whatever you want to use. So inside this component, I implemented just 3 functions: transfer ownership, get owner, and renounce ownership. In my renounce ownership, I just transfer the component's ownership to the 0 address. Then I use generate traits here. I use generate traits here to write an initializer and put an internal function here. All this was explained in last class. So when using the components, previously, before I used the one from Openzeppelin, what I did was use create, right, components, enable components, and almost everything is normal again, except that I need to change some things. When I wrote my initializer, I put an underscore before it. Like this is it. I put an underscore before it. So to use it here, I have to put the underscore. Then my assert only owner is not like this. It's like this, and I have to pass a color address. So get color address. This is how it is, by the way, color. So I don't want to go over how I implemented everything here, but the 2 and 2 of it is that I was able to consume the component I wrote within this contract. But instead of always writing our components from scratch, I mentioned that Openzeppelin is a library that provides ready-to-use components for you. The thing about using Openzeppelin components is that you just know that it's secure. There is this thing when you are working with components called VM transfer. So there are times where you might use a component, especially when using two different components. You might call a function. Okay, say you have component A and component B. You might call a function that is in component B from component A without knowing that that function in component B already calls the same function in component A. So like it's going to just give you an endless loop of different calls. That's an example of reentrancy. So the thing with Openzeppelin components is that they are audited. So you know that there is no danger of reentrancy, there is no security hole, there is nothing. It's ready to use just like that. So I instead imported the enable components from Openzeppelin. The storage, I use this to some storage video. If you watch the previous class, we're going to see all of it on the previous class. I just don't want to go over the whole thing again. I use the functions, I declare the implementation, and instead of opening square brackets, I just call it from here like this. And I use when I want to use the functions, I'll say self.enable. That's I'm using the component storage dot assert only owner. So I did them in like different parts. So the next thing we talked about is how to interact between two different contracts using dispatcher. Now I mentioned that what Starknet interfaces help us to do. And I know my method of teaching now, you thought I was going to explain from what a dispatcher is. No, I'm going to talk about interface. What interfaces do is that interfaces define function signatures, right? So when you write an interface, there are some things that come with it by virtue of you adding this decorator Starknet interface. What do I mean? Hold on. Okay, say I want to import this now. Use super. The interface I implemented is just iStudent local, but it has derived all these things for us. iStudent local dispatcher copy, dispatcher drop, dispatcher this, dispatcher that, library. It has derived a lot of things for us. So that's what happens under the hood when you use this Starknet interface decorator. So this dispatcher helps us to call, since an interface defines the function signatures, this dispatcher helps us to call the functions. It's just like using ABI from the front end. Okay, I was supposed to do that. That's supposed to be like for the 7th week. But it's just like using it's just like using ABIs from the front end. You use dispatchers within components or contracts where you want to call another contract. Now, I practiced how to use it in that after I have this bookstore contract, I started writing another contract called the student local. The logic was that in the bookstore, the functions we have are add book, remove book, borrow book, return, get books, and get book. So when we're assuming that the person that borrows a book is a student, Sorry. 2 seconds.
And then let's finish 1 second.
So who is still with me? Now in week 3, all of you were crying that you wanted to see code. Now everybody is running as well now. This is the code. Please don't run. So the logic is that when someone borrows a book, we assume that the person that borrowed the book is a student. And the book the person borrowed goes into the student's locker. And when someone returns a book, we assume that the book goes out of the student's locker. Do you understand? I believe you do. Now, we're also going to need these get books in case the student needs a particular book and he needs to see the books that are available in the bookstore. And we're going to need this get book if the student needs a particular book. So in this interface, I just put 4 functions: list bookstore books, get a book, which is a book, return a book, and list. This my event is complaining because 2 of them are. Let me just change this book returned because I don't like saying this rate. Returned. Book returned. So that's what's going to happen. The list bookstore books is going to return an array of all the books that the bookstore has. The get a book is going to call this borrow book from the bookstore. The return a book is going to call this return book from the bookstore. And the list local books is going to list the books that the student has in their locker. So, okay, in the, let me call this student books, as books the students have. In the, okay, sorry, I'm going to call it local books instead. Local books, because I call this function list local books. So the next thing I'm going to do is that inside the storage, I added local books, which is a maps an ID to a book. I recorded this address of the particular student that owns the locker, and I have the address of the bookstore. Right? Yes. Then I implemented 2 events, which are borrowed book and book returned. They both return the book ID and the timestamp. So I'm just going to put this here, key. What this key helps is that when inspecting events, this key helps to be able to find events using this book ID under. That was something that you don't really need to be concerned about now. Now, let's look at this constructor. In this constructor, I'm taking the student's address as a contract address. I could easily say get caller address, but personally, I prefer to pass the actual address of the student since the deployer might not be the student that owns it. Then I was supposed to record the bookstore address. So I'm going to take another argument here, bookstore address, and it's also going to be a contract address. And then I'll say self dot bookstore address dot write bookstore address. Does anybody understand what just happened? Any questions so far? No question.
Well, I don't understand the last thing you did.
You mean adding this bookstore address?
The constructor.
The thing is that, sorry?
What does constructor do?
I can't really hear you.
What does constructor do? Yeah, like, I don't know if it's different. Is he the same as initializing what's it called?
This is a contract. This is not a component.
I mean the constructor.
Yes, a constructor runs at deployment now. Every contract has a constructor. It's components that don't have constructors.
Okay.
Any other question?
No.
Okay. Why I added this line is that in this storage, I'm supposed to store the bookstore address. So if someone deploys this contract and tries to get the bookstore address, the person will not be able to get it because in the constructor I did not initialize it. Like I didn't write it to the storage initially. That's why I added this line. And I added this argument. So the first function that I implemented is to list bookstore books. So this is just to list the books in the bookstore. So what will happen is that instead of in this contract, now in the actual bookstore contract, to get books, what happened is that we first initialized an array, and then we used the counter, we did all of this, and for each book we get to add the book to the array, and then we return the array in the end. But here, what we want to do is we just want to call the function from the bookstore. Do you understand? So from this place, we want to call this function. And what will help us do that is the dispatcher. I imported the dispatcher here. I used create contract bookstore. I imported iBookstore dispatcher. The iBookstore is from the interface. iBookstore dispatcher and iBookstore dispatcher trees. Both of them are important. Whenever you get a dispatcher, also get the trees. So instead of doing all of that, what I did in the get books function over here, what I just did is let bookstore address equals self the bookstore address the read. I'll read the bookstore address from storage. Yeah. Then to be able to interact with it, I'm not going to say let bookstore is equal to iBookstore dispatcher. It takes in one argument, which is the contract address. And I'm going to pass the bookstore address as the contract address. So once I do this now, I can use bookstore to call any of these functions. any of these functions here. So I could as well say,
Hello?
let's boom.
Can
Can you hear me? I can hear you. I can hear you. Sorry? Can you hear me?
I hear you, I'm hearing you, I'm hearing you.
See, look at what I've just done now. I called the return book and it's giving me an error. It's saying a wrong number of arguments expected. So I'm just going to put 1 as the ID, for example. And there is no more error. This completely works. Do you understand? Because since I've used this dispatcher, I've established a communication line between this contact and the other one. So I can call any of its functions. Is anybody following? Any confusion? Oh, I better hope not. But that's not what I'm here for, sure. I want to list the bookstore books. So what I'm going to do is, I'm just going to call the get books. And if you look at this, the get books returns an array of books. And what we want to return here is also an array of books. So instead of saying, we can actually say, let books equal to this, and do like this, books in the end. It's going to return our books, but there is no need to do this. Always never initialize, never use a variable where you don't need a variable. That's one thing I do, because variables cause leaks and all that. So I just did bookstore.get books. I did not put semicolon, which signifies that I'm returning whatever this function returns. Does anybody understand? Is anybody following? I hope. Okay. So the next thing, I'm going to list the books that are in the locker. I'm just going to copy it from here. Because it's like the exact same kind of thing. It's the same situation, just the same situation. I probably need a local book counter. And it's going to be a simple UX. So I'm going to come down here, local book counter. This is local books. And I've implemented the function. Don't worry, I just copied the logic from there. I didn't use dispatcher in this one. Then for this get a book function, we want this get a book to call this contracts borrow book. And inside here, what the only argument you need is the ID, which is like same as this. But to get a book. Okay, I actually didn't return this. Oh, I didn't think this I didn't think this thing through well. But in the real world, this contract is not going to work, sure. I'm just demonstrating how dispatcher works. So I'm not going to say let's bookstore address, just like I did in the above function. Go to self.bookstore address.read, right? And then I'll say, let's bookstore, or I can say bookstore contracts is equal to I bookstore dispatcher. Contract address is the bookstore address. And I'll now say bookstore dot borrow book, and I'm going to pass in the book ID as an argument. And you can see that it works. The compiler is no longer shouting. I'll do the same thing here. Let bookstore address be self bookstore address read. Let bookstore I bookstore dispatcher contact address bookstore. Yeah, I have a question.
I just wanted to come on the mic.
Okay.
Um,
Book ID.
so the dispatcher
And
is
each time, sorry?
see the dispatcher, like it's used to like maybe transfer, it's used to like help if you are in another at the component, you can get the function, something like that.
It's actually between two contracts. It's used by another contract to call the functions of another contract. Like
Okay.
it's used by a contract to call the functions of another contract. And each time, we actually don't need to emit our events here. Because each time, but we can, but we don't need to. Each time this contract calls the functions of this bookstore, the bookstore is going to emit its own events. Do you understand?
Mm-hmm.
Because in the function, emitting events is part of the logic. So it actually recognizes that something outside is triggering it. But since we defined events, it doesn't make sense that we're not going to emit them. So let's emit the borrowed book and book returned. Just come here, self.emit borrowed book and book ID timestamp, which is get block timestamp. Okay, we not. So I'm going to put it here. Get block timestamp. And here, self.emit book returns. We have the book ID and the timestamp as get block timestamp. So yeah, that also works. Do you understand? Any question? Any question?
Okay, no, I don't even know how to ask this one. Like,
Ask anyhow.
okay,
Anyhow, it is in it.
from what I saw, excuse me, can you go back to the code?
Should I go back to the code?
Mm.
Okay.
You know, here now, it's like you said, you're like emitting. Okay, we didn't use this book return, but you want to like also update it on the something
Only
like
student local. Yes.
so that it will also be updated like with this latest ones. Yeah.
With its latest.
No, I mean like this. Oh, it means this ones up here, like this bookstore address and bookstore. They are the ones that okay, bookstore address. I don't know if you can explain a bit this function return a book.
Okay. What I just did is, do you understand this? But do you understand this get it?
Do I understand what
This
get a
get a
book?
book function. Yeah. It's
No,
the
I don't.
exact same thing I did. Okay, what I first did is I read the address of the bookstore from storage,
Mm-hmm.
right?
Mm,
After reading the address of the bookstore, I then use the bookstore's dispatcher.
okay.
Uh,
Okay.
I use the bookstore's dispatcher and put the contract address of the bookstore, which is this bookstore address. A dispatcher is a struct, and it has one what's it called? A dispatcher is a struct, and it has one property, which is the contract address. So I put the contract address here as the bookstore address. So this way now, I can use this bookstore variable to call any function that I need from the bookstore. Do you understand?
Mm-hmm.
So that's why I was able to call this borrow book, bookstore.borrow book, because inside here we have this function called borrow book. That's also why I was able to call bookstore.return book, because inside here we have this function called return book.
Okay.
Aorta.
Mm. Over.
That's also why I was able to call get books. This is why I called get books, because in this function we have get in this contract. So any other question?
No, just the question was just this place you started writing self.init borrowed book, then book ID, you gave it a
Oh,
time stamp.
oh, that was just me emitting events. I defined the event up here. This is the events for that I would like to emit when a book is borrowed, and this is the event I would like to emit when a book is returned. So it's also a struct, and its properties are the book ID and the timestamp.
Okay.
So that was why I was able to emit the events. I hope you are following.
Yes,
Anybody
yes.
else? Huh?
No, I didn't say anything else.
Okay. Okay. So the next thing we are supposed to do is we are supposed to write an ERC20 contract. Do you understand?
Mm.
But I think you must have written an ERC20 contract last week. Yes or yes?
I wasn't here, Jesus Christ. You know.
Hmm?
Those who are around should notify, man. I wasn't last week. I wasn't even around.
But the difference between last week's own and this week's own is that this week we are supposed to use components instead of writing all the functions from scratch.
Okay.
So I'm supposed to demonstrate how to use components to implement the ERC20 instead of using contracts. Is anybody following? No, if you're following, oh.
I'm following.
We're following. We did the ERC20 contract last week.
Okay. So what I said is that the difference is that in this week's one, we are supposed to use components. We are supposed to try and write minimal logic, almost no logic at all. Just using components from Openzeppelin to implement the ERC20. So it says the contract. I'm just going to do the same things that you know. First, start with Starknet interface, right? And say portraits I token. And the type is T. So function means ref self T and amount, the amount you want to mix, and the amount is going to be YouTube. Now, the compiler is not telling me anything. It's acting like it's angry with me because I have not put this token sale inside here. It's inside the folder contracts. So just like with Bookstore and Student Locker, I'm going to say pub mode token sale. So if I remove this now, look, the compiler is shouting again. So the next thing is Starknet contracts and pub mode. Okay. It's going to have storage. I've not decided what I want to put in storage yet. You're going to have I don't need to implement this myself. It's already but I'm going to import this contract address. And then to implement a complete ERC20, I'm also going to use the enable components. Okay. Instead of doing it this way, let's just do it together from Openzeppelin. So I must have sent this yesterday, but I'm going to send it again.
So it's actually so that it's countries this 6 weekend. I don't know again. So these agents 1 20 seconds actually expire. I'm not on this way, it's the trade. But mainly it's just choose a particular.
Sorry, just let me get the components.
So let's using okay.
So this is the ERC20 components.
Okay.
It's okay. This model provides interfaces, presets, and according to ERC20 guide. So what I'm going to do is this is how to get like the dispatcher. Let me look for.
So that I really appreciate. So everyone that is in an access stores.
Okay.
And I'll go to your journal and be like, okay, this tree.
If I this is what I use if I want to import it, right? So instead of Openzeppelin token, in my Skillup.tml, what I put as dependency here is just Openzeppelin. So I'm going to use just Openzeppelin. So this is how you do it. You use Openzeppelin. I'm supposed to show me what I have. I'm going to predict ERC20. ERC20 components. So this is where I'll stop.
So that's it. So really going about the today. And share with the opportunity streets and street strong but it's easy of them right now.
So I have imported it. Let me just check for the simplest.
So we wrap up the stream exactly by 10
There is no difference of opinion than emotion. They updated their site in the past few weeks or months. So. But I'm not going to do it anyway. The next thing is that the same way we use components in the storage, I'm going to use this sub storage v0 and I'll say ERC20 as the name. Then ERC20 components dot storage. In my events, I'll do the same thing. In events, I'm going to derive, draw, and Starknet events. Then I'll use flags and name the events. ERC20 events. And say ERC20 components events. And then I'll come down here. The next thing is the constructor. So constructor, function constructor, ref self, contract states. Owner. I'm not going. Okay, it's my choice to use it. I can actually use the ownable components so that before the main function, I'll assert that this person is the owner of this token. But I don't think I want to do that now. So I'm going to call the initializer of the ERC20. Oh, sorry. The next before I'm able to do that, I'm going to have to come down here. Sorry, and declare that I'm using this component. So components, I'll give it the path, which is ERC20 components. I'll give you the storage, which is ERC20, and I'll give you the events, which is ERC20 events. So this part just means this ERC20 component, which is this points to the component that is being used. This points to the name that we use to store it here in storage. And this points to what we implemented the event as. That's why I said ERC20 events, just like this name here. So now that I've done this, I can easily say self, okay, sorry, pub info ERC20. Okay, I'm going to do this. Is equal to ERC20 components, ERC20 metadata implementation, and contract 6. Sorry, excuse me. Yeah, that's exactly how it's supposed to be. Let me check Openzeppelin again. Why is it showing this way? Let's obviously this is not the issue, so okay. A minute. Can you see my screen? So let me see if it, yes, it works. So there are different implementations of this. What I just did is I actually needed to import this as well. So according to Openzeppelin, there are different implementations of this. There is the mixing implementation, there is the regular implementation. There are different implementations. The camel case only, which is not what we're going to use. There is ERC20 permits. There are different implementations that we could use, but the most common is actually not this. The most common is the ERC20. Let me remove this. ERC20. Is this the spelling? Yes. This is the most common. But we can actually use any of them. So what we have just done here is that we define this implementation and this implementation. In the constructor, we are now going to initialize our ERC20 components. So self.erc20 dot initialize is this the name of the function. No. What's the name? Okay, it's called initializer. Look at it here, initializer. So initializer, exactly. And what it expects is it expects a name as a byte array and a symbol, which is also a byte array. So let's name be equal to Skillup Token. Let's symbol be equal to SKT. So we'll just pass the name in here and the symbol in here. And we have initialized our token. So the next thing is we actually didn't need this type even. I'm going to say use super. And I'm going to take I token. So the next thing is we're going to write an implementation of the interface. So token info of I token contract states. Well, just imagine. So it tells us that we have not not all three items are implemented. So I'm just going to copy this. put it here as the main function. Jesus, now I feel like I'm talking to myself. I mean, I know you are there, but I feel like I'm talking to myself. Self.erc20 dot mint amount. Okay, it expects a recipient and an amount. So I'm going to say let's recipient be equal to get caller address. Get caller address and recipient amount. So yes, that is all. We have implemented the token without writing all the different functions. Instead, what we simply did is we use the component from Openzeppelin. So who does not understand what's happened here? No, everyone don't even. Who does not understand what we did here now? Any question? I guess there's none. And finally, I'm just going to scrap build to confirm we don't have any errors. Okay, so this is wasting on an unusual amount of time. No. But what we have done, as I said, is that we implemented an ERC20 contract without needing to do what? To write all the functions that we had to write last week. That's the balance of approved or approved, get allowance, and all those things. We just use the components from Openzeppelin. In fact, I can actually decide to remove this block and leave just those two implementation layers. And my contract is actually complete. So I'm just going to keep waiting for this thing to build. Why is it taking time? Let's give it 30 seconds. If it does not build in 30 seconds, we are going to close the vscode. No, me, I'm not going to understand the game. How many things are inside here? Like, wasting time like this. Oh, now I see the issue. I see the issue now. So this is to encourage those that use WSL. I face the same issue sometimes. My WSL just stuff. Okay. What did I do before again? Stop it. So that's like what, just look at it, reconnecting. This is what I'm going to do. I'll close it. I'll press Windows R, CMD, and WSL shutdown. It closes my WSL, and then I'll open it again. So easy, basically refreshing it. So that's like an easy hack, easy whatever you call it. And this time it's actually going to be much faster. Meanwhile, there is another branch here now. Let me refresh this. There is a third branch here now. So let me just send that as well. Oh, no, it's asking me for the students. Ah, see, it completed. Unlike some of your own, it has finished. It's completed. So the last thing I'm going to do is to show that to demonstrate that over here, that's inside this token seal, that we by adding just this implementation, we actually have all the ERC20 functions now. I'm going to come over to ANG and I'll come to token. Let's see the functions that we have inside. Look at it. The only thing we wrote inside here is mint. That's the only thing we wrote ourselves. But because of the components, we now have all these functions here. We have total supply, balance of allowance, we have all of them for it. So do you understand? That's what components do for us. Also, in this bookstore, did we add this to our ABI? Yes, we added the Onebo implementation to our ABI. That's by using this ABI embed. That means what we are going to see here, where is it? In the Skillup bookstore, is not just this, it's not just the functions from this. We're also going to see functions from the Onebo components. Now look at it. Get implements ourselves. All of these were gotten from the components. And okay, there's really nothing special in this one. It said that when we get a book, when we call this function from here, it actually updates the state of this bookstore because we use this pattern. We use this pattern. So if I want to do the interaction, what I'll do is that I'll first deploy this bookstore. When a student wants to organize a bookstore, the book has to be existing for the student can use the books data in the log. So I'm going to also I'll deploy this. After deploying, I'll copy the contract. I'll come use this function, get the book. It's going to call this is here. It's going to call the borrow book here. And if we now check length books, okay, we didn't implement that on the page. But if we check length books, if we have done it, we'll see that a book has actually been borrowed from this, even though we didn't call it directly from here. So that is what components do for us. Jesus. Don't tell me about plus. Can you see my screen? So that's what components do for us, and that summarizes what these patterns do for us. Next week, we are going to be learning how to use Starknet Foundry to write automated tests for your smart contracts. If you are testing using AMP, all you are doing is manual testing. We are going to be learning how to use Starknet Foundry to write automated tests next week. So, in my opinion, this was a good class. And keep writing, Cairo, keep learning, keep reading. Whatever issue you have, my DM is less than a stone throw away. It's just a text away. And I wish you good luck in next week.